Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 1.8 entitled An Introduction to Functions. And today's goal is going to be to make an input-output table for a given function. And sometimes instead of calling that an input-output table, we call it a function table. So today we're going to look at a function, and we're going to make tables and graphs based on that function. But first we have to understand what exactly a function is. And a function is a rule that establishes a relationship between two quantities. And those two quantities are going to be called the input and the output. So a function, if it's a rule, usually it's written as an equation, maybe something like that. So input would be all the stuff that you would put in for x, and output would be all the stuff that you get out for y. So these functions can have a lot of different forms. These are just some examples of what a function might look like. Okay, but the input is also going to be called the domain. And again, those are all the x values that you substitute into the function. And the output is going to be referred to as the range. And those are all the y values that you get when you solve the function after you've substituted in the x value. Now there's a very strong relationship between the input and the output values of a function. Now this note here must be really, really important because it's written in red, it's all capitalized, it's got stars by it. It says for each input value, there is exactly one output value. And the way I explain this is kind of like a vending machine. I say a function is like a vending machine. You know how a vending machine works. You take your money, you put it in the machine, and you push the buttons, and the machine kind of goes clunk, 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 and then out comes whatever you were buying. Okay, so the money is kind of like the value that you're putting in, and then you're pushing the buttons, and the machine's going clunk, 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 and that's kind of like you simplifying and working through the actual problem, and then whatever comes out of the machine is kind of like your output or your value that you get out. Now, when you're dealing with a vending machine, usually if you push a button for Pepsi, you expect a Pepsi to come out of the machine. If you push a button for Pepsi and Dr. Pepper comes out, that's not correct. The machine hasn't been stocked properly. So we're going to take a look at these three examples down here, down below, and we're going to figure out if they're a properly functioning machine or not. And for all of our input and outputs, all of these three little tables here, we're going to look at them one at a time. Okay. So this first group here, here's one input and output table, and we're going to decide if this is a function or not. So for my x value of 2, if I put 2 into the function, I get 5 out. If I put 3 into the function, I get 7 out. If I put 4 into the function, I get 9 out. So each number that I'm putting into the function gets me a different number out. If I put 2 in, I get 5. If I put 3 in, I don't also get 5. Okay? So this is a function. This is a properly working vending machine. If I push the button for Pepsi, I get Pepsi. If I push the button for Diet Pepsi, I get Diet Pepsi. If I push the button for Dr. Pepper, I get Dr. Pepper. Okay? In the next function, this one's a little bit unique because I have 3 x values that I'm putting in, but I get the same y value out every single time. So now we have to ask ourselves, would that be a properly functioning vending machine? The values of 1 and 5 and 10, those would kind of be like 3 different buttons on the machine. And then I would get out 8 and 8 and 8. No matter which button I pushed, I would get the same thing out. And yeah, you can actually have that. That is a function. You could have a machine that had 3 buttons all designated for Pepsi. And this last set of columns here, this last input-output table, has a bit of a problem in it. This says if I have a button for Pepsi, I get a Pepsi. And then it says if I have a button for Pepsi, I also get out something different. I get out, let's say, a Mountain Dew. Okay, I can't put 11, the value of 11, into some equation and get an answer of -2, and then put 11 back into that same equation again and get an answer out of -7. That's not possible. So this is an example of not a properly functioning function. So this is what is meant by saying that each each input value, can only have one output value. Okay, so again, this overlap here, let me change colors a little bit. This repetition right there, I have two values in the x column that are the same, and they have different y values in the y column. That is the key for what you want to look for a not properly functioning function. Now, we could actually write equations for these first two tables here that were functions. This first function is actually the equation 2x plus 1. If I take the value of 2 and I substitute it in, 2 times 2 is 4 plus 1 gets me the value of 5. Okay, so that is a properly functioning function. And this other equation, when all the y values are the same, this function would be y equals 8. It would be a horizontal line if we were to graph that. And that would pass the vertical line test. We'll talk more about that later when we get to graphing. But just for now, just think of like a vending machine for this example and how it's okay to have more than one button that is designated for a certain type of Pepsi or whatever. Okay, so now that we've understood a little bit more about what a function is or isn't, we're going to actually make our input and output table for this function that we're given. And the function that they gave us is 3x plus 1.5. Now when you make your table, you want to have the first column for your x values and your input. Until we get really awesome at our functions, we want to have this middle column as well. And this middle column is going to be our work. This is where we're going to put our equation, 3x plus 1.5. And then this column here, the y value, that's the answer that we're going to get out when we do this middle column. And here they're actually going to tell us the values that they want us to use. They want us to use 0, 1, 2, and 3 as our domain. Again, domain is all the x values. So I'm going to substitute in 0, 1, 2, and 3 into my first column. And then I'm going to substitute each of those in one at a time to my equation, to my function. And then I'm going to simplify it and get my answer. And that answer will be my output value. So 3 times 0 is 0, and then the plus 1.5 is 1.5. Then I'll do the next one. 3 times 1, that's 3, plus 1.5 is 4.5. Then I have 3 times 2, that's 6, plus 1.5 is 7.5. And then there's 3 times 3, which is 9, plus 1.5 is 10.5. So there is my input and output table for that function. Now if we were going to graph this information, we've talked previously about line graphs and bar graphs. And actually when we start to graph functions or graph the equations, we're going to use line graphs. So that means that we would plot each of these points like an ordered pair. And we'll talk more about that when we get into our graphing chapter. But an ordered pair has the x value and then the y value. So we would plot that point on a graph. We would plot each point in this table, and then we would connect them all to form our line. And this would be a straight line when we connect it. And we'll also talk about slope and rise over run, all that good stuff. But just for now, we're focusing on making the table. And just know that in the future when we graph these, they will be line graphs. Okay, example 2, we've got a little bit of a story problem here that goes along with this one. So we're going to write the equation first, and then we will make our table. So you are riding in a hot air balloon at an altitude of 900 feet. You turn on the burner. So that's that little device where you pull the rope on it and the gas ignites. So you turn on the burner, and that raises you 25 feet per minute for 5 minutes. So we want to write an equation or the function to describe this situation. So you're starting at a certain height. So you have your starting height. I'm just going to kind of write like a little word model here. And then you turn on the burner and you rise a certain amount for a certain amount of time, a certain number of minutes. So you would take that distance that you rise and you would multiply it by the number of minutes. Okay, so like I said, you would take that rise and you would multiply it by the number of minutes that you rise. So I'm going to put a box around how far you rise, and we're going to times it by the number of minutes. And then that will get you your final height. Okay, so I'm going to rewrite this equation just a little bit. I'm going to plug in the information that we know. I know my starting height is 900, and I know I rise 25 feet, but I don't know the number of minutes, so we can just call that m, the number of minutes, and that will equal my height. Now usually when we're graphing and when we're dealing with input and output, we use the variables x and y. So I'm going to change this just slightly, and I'm going to rewrite it as 900 plus 25 times x, because the number of minutes would be the number that I'm putting into my function. And then I'm going to set it equal to y, because y would be my output. That would be my height that I would get out. Like I've said before, it doesn't matter what variable we use. We can use m's or h's or x's or y's. It doesn't matter. We just have to remember what they represent. Okay? So this is my equation now that I will be using to complete this table. Now this table I purposely put horizontally because you don't see many tables written this way, and I don't want you to be confused when you see a table written horizontally. Now the directions for part B say to make a function table to show how much you rise during each of the 5 minutes. So we've got 1, 2, 3, 4, and 5 minutes that we're going to substitute into our function. I'm going to put my function over here, and actually I'm going to write it as 25 times x plus 900, because it'll be easier to do the 25 times our x value and then add that to the 900. So 25 times 1 is going to be 25, plus 900 is 925. And then we'll do 25 times 2. I'm going to substitute that in. So this is like the work column that we did in the previous table. So 25 times 2 is 50, plus 900 is 950. Then I have 25 times 3. That's going to be 75. So that'll be 975 for my total. Then I'll have 25 times 4. That's going to be 1,000. I'm sorry, 100 plus 900 is 1,000 for the total. And my last one is 25 times 5. That's 125. Plus 900 is 1,025. So hopefully you've noticed a pattern that we're rising 25 feet every minute. Each of my output values gets bigger by 25, and that's good. So if we were to graph this, we would have a straight line that we would be able to graph. Okay? And I'm going to draw my axes, my x and y axes. And actually, I just need to draw the first quadrant. And again, remember, across, or the x values from our table are input values. Those go across the bottom, or the x-axis, or the horizontal axis. So I'm going to have 1, 2, 3, 4, 5 minutes. And then for my height, that's going to go on the y-axis. So I should label these axes as well. This is going to be time. And we could say time in minutes. And then on my other axis, I'm going to have my y values. And the y values were our height. Okay, so I'm going to have my height on my y-axis. And the height was in feet. So I want to make sure that I label that. Now, I'm really only going from about 900 feet to about 1,000 feet or so. So I'm going to put like a little zigzag across the bottom of my graph here to show that I'm going to start at 900, 925, 950, 975, 1,000, 1,025, 1,050. So I'm going to start at 900, 950, 1,000, and 1,050. Okay, so that way I don't have to start all the way at 0. This little zigzag is a break in my graph, so it tells anybody who's looking at it that I've kind of zoomed in on the important information. So when we started flying in this hot air balloon, we were at 900 feet before the burner was turned on. So really, it's kind of like we have an extra little column here on our table. And our starting time at 0 is going to be 900 because we'd have 25 times 0 is 0 plus 900 is 900. So really, if I'm starting my graph, at 0, I'm starting at 900. That's how high we were before we started turning on the burner. And then at the first minute, I was at 925. The second minute, I was at 950. Third minute, I was at 975. Fourth minute, I was at 1,000. Fifth minute, I was at 1,025. So this should be a relatively nice straight line. Now, granted, I'm drawing it by hand here, so it's going to be a little off just by human error. But if we had nice, neat graph paper and a ruler, it would be a perfectly straight line. And we want to put a title on this. So, hot air. Oh, I don't know why it keeps doing that. There we go. Hot air balloon ride. Okay. So hopefully you can see that when you're making your table, you're just substituting in values. We're going to write our equation kind of like we've done in the past in this chapter, where we write our verbal model and then we have our algebraic model and then our equation. We substitute our values in to make our table. And then when we graph them, we will definitely get a line graph. A line graph is a little more preferred than a bar graph. So there is your homework to practice these concepts. If you feel like you want graph paper, make sure you get some graph paper. If you have your own, feel free to use it. If you have questions, stop on by and see me before school.